Hi guys. Lesson 9.4 isn't really new material, but it's putting together everything we've done from the whole chapter so far. So I'm going to choose to use example or homework question 3 to teach this lesson, because I'm not really teaching anything new. What I really want to do is make sure you do the homework right, because there's a lot of steps to remember, a lot of things to do. First, you're going to put this data in your L1, this data in your L2, just like I have done right here. Okay, so this is your L1 and your L2 data. Okay, so get that in. The second thing you're going to do is actually your linear regression equation down here. So you would go to your stat, calc, choice 4, linear regression, and you get this screen right here. Okay, so my linear regression equation is y equals 16x minus 42. You're also going to record your r value. 0.97 is fine. Okay, so far, right now with an r value of 0.97, I'm thinking, oh, that sounds pretty linear. Okay. Then, move this out of the way, What you need now is you can use this line of best fit equation so that you can get your prediction. Okay, so your linear regression equation, oh, I didn't mean to do that. Linear regression equation goes into your y equals, okay, and your table. Let me show you something. Okay, so here it is, 16x minus 42. If you go into your table right now, the default when you clear the memory on your table is to start at 0 and count by ones. And you don't have to change that if you don't want to. The problem is, if you don't change it, you have to be really careful. Let me pull this out. Okay, if you don't change it, then if this says an x value of 1, then I'm going to put negative 26 here. This says an x value of 3, so I'm going to put a 6. I can't just blindly copy every number out in the chart because I'm not using every number in the table. So you can do that, although and this is not that awkward because we're only counting by 2s. But if you're counting by 10s or something, you'd probably want to change your table set to count by something else. So for us, take the 2 extra seconds, go in there, second table set, my data starts on 1, and then it counts by 2s. And now I have the values that I can just copy one by one into my chart. Okay, easier to do that. Move that down there for now. All right, then let me erase this mark because we don't need that anymore. Your residuals. Okay, your residual is the L2, your y value, your actual y value minus your predicted y value. First one threw off a lot of people. 2 minus negative 26. A lot of people wanted to say negative 24. That would be adding 2 and negative 26. Remember, this is 2 minus negative 26. Double negative makes a plus. This is actually 28. 10 minus 6 is 4. 26 minus 38 is negative 12. 50 minus 70 is negative 20. 82 minus 102, also negative 20. 122 minus 134, negative 12. 170 minus 166 is 4. 226 minus 198 is 28. Now, guys, huge coincidence that it goes 20s, 12s, 4s, 28. So that's a huge coincidence. Okay, so don't read too much into that. All right. Okay, so that's our tables. Going down to our graphs. First of all, I'm super annoyed that the homework people gave you calculator screens to draw in, because that's super annoying. So in class, I did offer you graph paper if you wanted to draw your graphs on graph paper instead of in the homework packet, because that's super annoying. If you still chose to do it in the homework packet, then here's, like, this graph doesn't have any markings on it for you to label. Super annoying. So I just counted it out by 50s. Why? Okay, don't forget that, let me back up a little bit. Back up. In your scatter plot, you're graphing the x-axis with your x values and the y-axis with your y values. Okay, so this is the scatter plot. It's not the residual plot, it's the scatter plot. Okay, my highest value in the y is 226. So counting by 50s, I get up to 250, and I can start plotting those points. Now, x-axis counted by 2's in the data, but notice I counted by evens. Well, that's because I can't start at 0, then count by 1 on the first box, first line, and then count by 2's ever after. That's not acceptable in the world of graphing. So you have to, you're going to have to count by 2's, evens, and then just, you know, graph in between boxes. So L1, we got 1, 2, and 3, 10. Super boring to watch me graph, so I'm going to pause my recording so I can just finish doing the graphing part. I'll be back in a sec. Okay, so now they're all grafted. Well, my strong correlation of 0.97, now that I see the scatter plot, that looks like a slight curve to me. Maybe this data is not linear after all. Okay, now, so we're graphing the scatter plot, but we're also graphing the line of best fit. Okay, normally, guys, I would tell you to go into your table and graph all the points in your table. However, and then connect them to be a straight line. However, we already have a bunch of points on here that are data points, and it's going to be easy to confuse a data point with a line of regression point. So here's what I'm going to have you do. First of all, I'm going to use a different color so that you can totally tell the difference. I'm going to have you look at your table. All right, on your table, I'm going to have you graph only 2 points. Guys, these lines form a straight line. Connect, you only need 2 dots. I'm going to have you graph the smallest point you can fit and the largest point you can fit. So 1, -26 from my table does not fit because we don't have negatives on here. But 3, 6 does. So I'm going to go to 3, 6, and put a dot. And let's see, my highest y value is 250, but 21. And my highest y value is 250, and my highest odd number is 19. So these are two. That's too big. Okay, 17 and 230. That's gonna fit. 17 and 230. That's gonna fit. Nope. 17 and 230. Okay. Then take a ruler, a straight edge, whatever, and just connect those 2 points. Don't plot all the dots in the interim. You'll confuse which ones are dots that go with your data and dots that go with your line of regression. Okay, so that'll get you through your scatter plot and your line of best fit. That leaves us with graphing the residual plot. Here again, on the residual, I'm still graphing the x values, counted out the same way, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay? But the y-axis in the residual plot is our residuals. So if I look at my residual row, my highest number, positive or negative, is 28. So I counted by 5s to make that work. Now, there's no rule that says I have to absolutely label every one. Okay, so I'm labeling every other one. You can label all of them if you want. And then plotting those. So let's see, 1 and 28. Three and 4. 5, negative 12. Here again, I think it's probably pretty boring to watch me graph, so I'm going to pause it, finish, and I'll be right back. And there's my residual plot done. Okay? Last part, sentence. Your sentence, there's a lot of variation on this, but basically you want to say, you know, get to the bottom line and support it with evidence. Is this data linear or nonlinear? What does the evidence tell you? So, and you need to mention all three things. You need to mention the R value. You need to mention the curve in, I shouldn't say the data, I should say a curve in the scatter plot. I'm going to word that a little differently. And the residual plot. Okay? So you mention all three things, but how you word it depends on what you see. So in this one I said, although the R value is strong, I see a curve in the scatter plot, and the residual plot indicates the data is nonlinear. Okay, so you're going to write sentences along those lines. Okay, hope this was helpful. See you next time.